Hello student, welcome all of you on our YouTube channel and our video series of linear algebra. So this is lecture 8 for the B.Sc. student, B.Sc.TY student. Semester is 5th. Paper is linear algebra. You just focus this lecture number. At not necessary write again and again linear algebra, subject mathematics, paper linear algebra, B.Sc.TY, semester. Only B.Sc.TY. Linear algebra means semester 5. It not necessary, need not be necessary to write again and again. So, student, in previous lecture, we discussed some examples of vector spaces, and in that case, we have discussed first example, and that was if F is the subfield of K, then K act as vector space over the field F. After that, next example is V be the set of order tuple alpha 1, alpha 2 to alpha n, such that all these alpha I must belong to field F, whatever the field F. Then this set V is a vector space over the field F. We discussed these two examples. Now we have to discuss some more examples. Let V be the set of polynomials in X. What this indicate? F of X means set of polynomials in X. Set of polynomial in X. So this is set of polynomials. F is any field. F be any field. Now I take set V, set of polynomial. That means V be the set in which there is polynomial such that polynomial means P of X is equal to alpha naught, alpha 1x, alpha 2x square, and so on. Now this alpha naught, alpha 1 to alpha n and so on belonging to the field F. So here degree is not mentioned. Try to understand. V is equal to F of X, set of polynomials in X. But what about the degree of that polynomial? So it is not mentioned. So V be the set of polynomial. It is an infinite sets. So many polynomials belongs to that set V. So student, you can verify yourself. V is a vector space over the field F. Now we have to show that V is a vector space over the field F means that we have to show that some point, that is V plus is an abelian. V plus is an abelian. And second, external division, if alpha belong to field and this belong to vector space V, then alpha and nu belong to vector space V. And after that, that four properties. First property, alpha into nu plus omega is equal to alpha nu plus alpha omega. Second property, alpha plus beta, that is distributive, left distributive. Third property, alpha beta nu, that is associative, and 1 into nu is equal to nu. So remember these things. If any set given and we have to show that that set is a vector space, then which thing we have to do? First show that V plus is an abelian. After that, external division, and after that, these 4 points. If we succeed to show all these properties, V plus is an abelian, external composition, and 4 properties, left distributive, right distributive, and multiplication, commutative, and existence of identity, then that set is a vector space over the field F. So see here, this is a vector space V of polynomial. So set of polynomial is 100% abelian with respect to plus, because addition of two polynomial is again a polynomial. Now if and 0, no problem, then okay, we try it with see here, V is the set of polynomial, okay. So we try to show that V plus is an abelian. V plus is an abelian. So student, we try to show that V plus is an abelian. So any polynomial P of x plus Q of x, we get a new polynomial belong to V. No problem. If P of x be the one polynomial P of x plus Q of x other polynomial, no problem, Q of x plus P of x. Adding the P of x plus Q of x or Q of x plus P of x, both are same, that is commutative. After that, P of x be the any polynomial, the minus P of x be the other polynomial, adding them we get 0 polynomial. And 0 polynomial is the identity element over addition. Then associative satisfy definitely. Actually, this is the work, and it is very easy, and we are frequently repeating these things, so no need to explain it. Now P of x plus Q of x plus R of x, if we add firstly this and after adding this, or we can add P of x, Q of x, firstly this and after that this, no problem. Inverse exists, identity exists addition is commutative, closure property satisfy, and associative satisfy, and therefore V plus is an abelian. Therefore, V plus is an abelian group. Next, external composition. What is the external composition? Choose any element of the field F, and this is the any polynomial of that set V. Then alpha into nu again is in the V, definitely. Suppose you choose the polynomial P of x is equal to A naught or alpha naught plus alpha 1x plus alpha 2x square. And if you multiply this by the any constant number alpha, no need, alpha not alpha 1x plus alpha 2x square. This again belong to V. No problem. It is right. So external division satisfy. And if external division, no division, it is composition. Remember this. By mistake I pronounced it division, but it is external composition. So V plus is an abelian, external satisfy, then all four properties, these four properties must be satisfied. You check it yourself. Left distributive, right distributive, associative, and existence of identity. Next example we discuss. Next example. Vn be the set of, or first I write it, be the set of polynomials. Here Vn be the set of polynomials of degree less than n, of degree less than n. So here Vn is a vector space over the field F, and F be any field, then Vn is a vector space over the field F. So in previous example, there is no restrictions of degree of polynomial, but here Vn is the set of all polynomials of degree less than n. So this is the set V. I consider polynomial alpha naught alpha 1x to alpha n x power n minus 1. This is polynomial of degree less than n, where these all alpha naught, alpha 1 to alpha n belonging to the element of field F. So student, this is polynomial of degree less than n minus 1. Sorry, less than n. Less than n means take degree x power n minus 1. And all these alpha naught, alpha 1 to alpha n belonging to the field F. So this is also example of vector spaces with regular addition and regular scalar multiplication. That means usual addition of polynomial and usual multiplication of polynomial taking as operation. We will show that this set V is a vector space. So I suggest to you students, you try to verify this example yourself, because previous example we have discussed already. So you try yourself this example. So in the next lecture we will study some new definitions and one important lemma. So we will meet in the next video. Students, I hope you are regularly attending the class. You also remember one thing, that you do regularly study our online lectures and take textbooks from our library, or you can also download PDF of any books online, and then verify it, learn it. Okay, so we stop here. Thank you very much.